Trying to make sure that they all have. My mouth is usually enough. And the director of risk management and IT for General Motors is one of my faculty members, and he just made a job offer to 3 of my grants. Somebody else was asking if I had someone who would be willing to move out to Seattle. Hey, how about you? I'm good. How are you?
You can be right there. Give Charles his bag out.
Charles' bag.
It's Charles. Yeah, he's now up there. Yeah. Well, welcome, Suresh. So we have historically just kind of taken notes of stuff that's there, and at the end we've come up with like best in show or best overall, best in show, best number of students, best new project, best team. Sometimes if we've got big teams. Yeah.
Because we try to make it encouraging. We want to make them come back, and what are there, 200 this time, I think? 200 participants this time.
Like, so.
Yeah, I got to get your signature. I'm trying to convince the university that I need to order these, but I think I'm just going to order them and then say, oops, sorry, I'm off. Where are they going to put them? 6:30. Hackathon area.
This is it. Yeah. Well, so they're going to change this. And they'll put somewhere in here to make the happen.
Start. Set aside an area. Sure that friends right now we're looking at extension stage. Oh, which I refer to as a slum bubble. It's cheap and it's but we went down the street to Marriott residence. They want more new place. Stay there a little longer. Yeah, it's no distance. Anyway, so she's trying to do what she can. I don't blame Betty for it. I was in San Diego. She really thought about doing the last in San Diego. It's not a fun part. It's not a fun part for us. It's doing February. Where is it? Oh, I'll go to the page.
San Diego in January, February, whatever it is.
As opposed to Vermont
Yeah.
in February. Let me see how hard that would beat up.
So I usually go. I can't go this year. I haven't been really. And usually what I do is I go. I'm ready. Really?
Does that mean you have to make a decision?
All right, folks. Oh, this one's a little louder, I think, which maybe is a good thing. Okay, so hopefully everyone got me your presentations. I've tried to merge in all the pull requests. Worst case, if we get to the end and I don't have yours, we'll figure out. We'll do your presentation at the end. There's probably like 3 or 4 of you at least that I know of who want to either present off your own laptop, or if you've sent me an email, I'll try to access that and we'll get you at the end. But we'll start with all the ones that are in the GitHub, and I'll just kind of go through them in order to try to keep things simpler for me. but that gives you an idea of when you're up. So I'm just going to start from the top and work my way down. And if you can come on up, you can use my laptop, and it's a handheld microphone. And so to the judges, can you do 3.5 minutes? Okay. I told you 3 minutes, but we're actually going to give you a bonus 30 seconds and hope that that works out okay. But you might get bonus points if you actually finish in 3. Okay, so do we have the SRV6 folks around and ready to present? And I assume you want to do the PDF first and then the... Okay. All right, so we're 0 for 1. Let's try this with the next one. How about Acme Star? You guys here and ready? Okay, let me get you. You have a PDF. I can download that. Get rid of this.
So I had two projects. One is LoLa, loss latency trade-off, and the other one is the Acme Star implementation. Okay, so I had two projects. One on Saturday, the LoLa loss latency trade-off, and the other one is that I did on Sunday today is the Acme Star implementation. So what's the LoLa thing? Is a draft that came out 1 year ago in the transport area. Is basically a div-serve marking scheme, which provides a super simplification over the usual div-serve model. The assumption here is that traffic belongs to either one of these two classes, loss sensitive or latency sensitive, and that's it. You mark the application, the endpoints, mark the traffic appropriately, and let the network do the right things in terms of scheduling. The difficult part for this is convincing the application, the endpoints, that marking their encrypted traffic is provides an advantage. So we had this discussion during the Marnew workshop and Jakor both, and the discussion stalled because we had no data. So the main reason behind this effort is to provide the automated testing facility to actually collect the data and decide whether the mechanism actually works in practice and provides the advantage that it promises. So yesterday, I've worked on this, and what I had was already, I prepared the flow mix and the queuing implementation. So the focus yesterday was around data analysis. So I ran the flow mix through the queues and took raw packet captures at various places. And then what I had done is correlating them when needed, visualizing interesting stats. In particular, I was interested in queuing latency and drop patterns in relation to the flow mix dynamics. In practice, this effort was a couple hundred lines of T#, Oak, and R. The later was a first for me, and I enjoyed the superpowers of it a lot. And then today I've worked on Acme Star. This is a draft that we had just adopted in the Acme working group. It is an extension to the Acme protocol to automate the certificate renewal. So Acme provides issuance, automated issuance, and this one extends the thing to actually automate also the renewal parts. In general, this might be a useful extension, but what we like to do here is to use it in conjunction with another proposal that we have that spawned from the lurk, for those who remember that, birds of a feather. And in this is needed to allow cloud service providers or CDNs to obtain certificates for HTTPS delivery that bear the content provider name instead of their own. So today I've worked, this was synchronized, so we had a participant that was remotely providing the Acme Star implementation as an extension to Boulder and Setbot. While I was working on the other side of the protocol, the lurk bits, implementing them from scratch. Now we have the two bits together. There are still some moving parts, but we think we can already integrate them into an end-to-end demo, which comprises a portable mini CDN with DNS-based redirection and HTTPS delivery. This work has just started, and we plan to complete this by Singapore. Diego. Two.
Okay, so we'll go back to the SRv6. Yeah, let me know. When you want to switch, we can. I can't load both at the same time.
No, just record. Yeah, sure. Yeah, I would just move a little bit though.
This is going to fall off if we're not careful.
So maybe you can do the other direction. No, just move it a little bit here. I'm sorry, I'm such a trouble. I need to read my notes. Do I need to question? Hi guys, welcome to our segment routing IPv6 over NetConf presentation. Over the next 3 minutes, I am going to present our goal, which was when you take a DSL broadband LAN router, it usually does not have the capabilities like segment routing or NetConf. So we were wondering whether it would be possible to add this kind of functionality and how hard that would be. Also, we wanted to have a hands-on experience on segment routing technology. So those were our motivations. So what did we do? We took LAN router, which is very similar you can get from a broadband provider, and it was TP-Link. And we took DD, which is a firmware for a router which you can use to extend the capabilities of the router. We took the patch from David Lebrun, and it's a segment routing enabled patch which will allow to turn off this functionality on LEDI. Then, next thing we did, we wrote Young model, which is storing information we need in order to achieve segment routing. And in this particular case, it is storing IPv6 prefix and associated segment routing list. Then we took sysrepo, which is Young-based configuration and operational data store. And we wrote our own daemon, which is using the sysrepo hooks, which are triggered by NetConf server netoppeer 2. And netoppeer 2 is something which will enable you to issue netconf commands on the router. So I can show you a small presentation, the video. How do I do that? Oh, you probably need to click. Yeah, thank you. Yeah, this is it. Can you make it full screen, please? Yes. So as you can see on the right side, there is our topology. We have a client which is acting as a controller, issuing netconf commands to router A. Router A and router B are two routers using LEDI, and all those technologies I talked about integrated together. So they understand netconf and they understand segment routing. What we are doing is that at the beginning, we are pinging this bottom interface from router A, and it is taking the green path, like that. Now, at some point, we issue from the client the netconf command, and the new routing path gets installed on router A, and the packet will immediately start to take the upper path. And as you can see here on the left, the new route got installed. And then you can also see these two TCP dump screens, which are taking packets from these two particular interfaces. And you can see, if you watch carefully, that actually one and the other interface are receiving packets mutually, depending on whether or not the segment routing is enabled. So thank you very much for your attention. If you have questions, feel free to stop at our table, which is in that corner. We are segment routing V6 team, and we can discuss use cases, why that would be useful to have a segment routing on the endpoint. Thank you for your attention.
Judges, do you have any questions?
Is this a current working group?
Well, there is a Spring working group and there is segment routing. So we took what segment routing is discussing and we found a way how to implement it in the router, integrating all those technologies together and also writing our own piece, which is the repo. So the short answer is yes, it's Spring.
How many people are involved?
We are 3 people. Thank you.
Okay, our 451 status code, folks. Oh, yeah, this was an interesting one. We'll see how this works. You guys ready? Okay. Oh, let me make it full screen for you. And
Yep. So HTTP status code 451 tells you if a web page has been blocked by a sensor. And so we did stuff relating to that. There were some reports. You write some hack assessment.
Oh yeah, so we quickly analyzed the potential positive and negative impacts of the HTTP status code in real life.
Implementation reports.
So we built 6 different modules in all of which is a. Okay.
In the implementation report, we analyzed how the status code currently is being used and the impact the standards might have technically and whether they are compatible and whether the implementations are in line with the spec. And suggestions for improvements because a lot of things turned out to not be implemented in line with the spec. And we did edit a legal background with examples for India, Chile, Russia, Iran, and the US.
So we also had a bunch of different implementations, JavaScript crawler, web-based plugin for WordPress, which isn't just for a client, it's also for people on the server, block collector.
We're gonna, if we just get the screenshots on, and we can straight to them, and then we can. Yeah, let's go straight to the. Yeah. So we took all these together and specified 2 JSON formats that unify censorship reports from each of these disparate data sources. We ran one of the crawlers in Turkey to see the difference between countries, something that we intend to explore more, the difference between censorship, both through complicit actions by companies and also independent filtering, possibly as an extension. But mainly this is to validate the specification RFC 7725. So if we move on. This is the JavaScript crawler. This is a simple output which shows you 3 resources that we found that were blocked, which is LGBTI content, and this was in Turkey. And there's the WordPress plugin. So,
okay, so the WordPress plugin basically allows site operators to, instead of taking down content, marking it as blocked, they can configure to block it in all countries. Some countries they can say which authority has requested the block and why, and they can choose if they want to report it to the registry. Okay.
And all of these data sources are united in a centralized data collection module, the block collector, which actually allows you to also report on these in real time. So you can track new censorship incidents and as they happen at that URL. And it's the browser plugin.
Yeah. So the way it seems to work is that when you get to a web page that is blocked by or that reports 451, then you can report that to the block collector. And the Python crawler is pretty much just a desktop version of the web crawler and the JavaScript crawler.
We hope this is going to inform and bridge civil society and the spec world in weeks and months to come. So get in touch with us. We're right at the back. Thanks.
Thanks. What clarify something?
Yeah.
Clarify something for me. What I guess you crawled the web looking for web pages that were returning 451.
We crawl through a page looking for links on that page that return a 451 when navigated to.
Okay. And so what exactly did you do this weekend?
We added functionality to those we made the crawlers that go through the web pages. And the block collector also.
Okay.
And the plugin. Yeah. Yeah.
Thank you.
Like a lot. Like 10 to 12. Yeah. Quite a few people.
So the implementation report, is that going to be a draft or is it a draft already? Okay.
I think it.
Great. Well, thank you. Okay, so the next one is the DNS team. You guys up and ready? Cool.
Oh, I understand. Yeah, thank you. So these are the results of the DNS team. First, these are the participants, 18 people. Okay, sorry. It's in presentation mode here. No signal. Sort to take that. Now it's up. Yeah. Excellent. Yeah. No, this is fine. Yeah. So we had a large crew, 3 new IETF Hackathon participants. We're very happy with that. And with 18 people, your strength is also your weakness. So there are many people with many ideas and to work on. So we come up with a number of themes, but we worked on quite different subjects. First, I want to stress this. Education was actually also a good part of yesterday. So we really talked a lot with each other and with the new IETFers about what we have been doing in the past and where we are heading to. So that I want to stress that was important, and we spent some time there. Works on drafts. Sorry. So important new implementations of implementation of new drafts, like the elliptic curve ED 25519. Important to get implemented and deployed. Optimizations like DNS multiple queue type, so you can send a number of queries in one shot, good for performance. So we're working on DNSSEC security, resiliency, and performance here. As we also more and more rely on privacy on the internet, and also DNS is working on that. We are working on that. More and more DNS queries will go over DNS over TLS. So TCP is important. TCP fast open has been implemented, not. And DNSSEC chain TLS extensions, a long name for the draft, it allows DNSSEC authentication, the whole chain authentication, in one shot. So the transporter here is not DNS, it's TLS. So you get all the DNS key material in one shot. You can do the validation by the application, for example, in web browsers. Very useful. And we worked on the CDNS capture format and retrofit DNS tab, which is kind of a monitoring, well, it's a logging format for the internals of resolvers and name servers. And we want to retrofit that in CDNS, which is an broadly supported, or it's a new draft, but it got a lot of attention and support here. So that's good work here. Did somebody already told you that there's a KSK rollover, 11th of October? Remember the date. Actually, it started already 15 days ago. I don't know, no, 10 days. So the new key has been introduced on the 11th of July. But there's some extra testing of all the software. It has been already tested, so we extended the testings also in the DNS test tool, Deckard. There's support for not resolver and for unbound. These are the timeline, we can skip that. What has been forgotten with all the standardization in the IETF is that we have some automated update of the trust anchor, of the root, for DNS operators, the chef cook. But we forgot to specify what to do for our end users, the end-to-end principle. We forgot completely about that. So how do we deal with applications that has to catch up with the new trust anchor? So we came, well, the RFC 5011 doesn't work, unfortunately. Well, it worked for the operators, but not for the end users. So we came with a zero-conf hack. So it allows applications which depend on the DNSSEC, etc., for DANE, to do kind of an automated trust anchor update. I won't go in all the details, but it will check if there's an update on the trust anchors. If necessary, it loads them and can do the whole authentication locally in the application. Some research innovation, no standards here. We experiment with opportunistic TTL. We don't know if it will ever work, but it's good to test ideas here also with our colleagues. And of course, study goes on. The DNS privacy is important. So we've done some packaging and documentation to get it out and to be used by anyone, not per se DNS experts. That's it.
Any questions?
Yeah. So what part of this was done today? All of this, or?
So yeah, this weekend, going back, actually, yeah, everything by individuals, different individuals. So there was two people working on the ED, the new elliptic curve, the Edward curve. One person works on the Q-type. Two people on the TLS extensions. For this work, also 3-4 people. Also the new people were working on the Deckard testing, etc. So there was a good energy, with a lot of work being done.
And the issues you found in 5011, did you write them up, and are you going to bring it
Yeah,
back today?
indeed. Yeah, that's indeed. We were thinking of that, and we need to document this, and indeed send in a draft to repair this or to document this and get a draft. Yeah, thank you.
Yeah, great. Thank you. Okay. Did you see your name next in the list? Yeah. Dots. Okay.
Yeah, okay. Thank you. I'm Kaname Nishizuka from NTT. We developed a Go implementation of dots, and it is named Go dots. So most of people in this room could be not familiar with the dots. So what is the dot? A dot is a DDoS open thread signaling. And so that is a signaling for standardization and automation of the signaling for DDoS protection. So it is to say, ask for help from victim side to upstream provider. So it is inter-organizational. So inherently, it includes the authorization and authentication in specification. And vice versa, protection status information from the upstream provider to the victim is conveyed on also dot channel. So we opened the code. Yesterday, we just opened the code as an open source project. So this repository already have amount of code, but it is now open. So what was developed in the hackathon? We made the code easy to be deployed in various environments. So we made a kind of a Docker compose file to each services, and also we refined the complex part of configuration. And also we clarified the documentation because it is good for newcomers to this field. And also we made a demonstration of one user scenario. So it is the demonstration is on a portable Docker environment, so everyone can do that demo in everywhere. So the demo includes the triggering of black hole routing from victim side. So this is very interesting demo. So it attracted for people, and we showed them a demo in this weekend. As the next step, it is now OSS, so we'd like to adapt to the various deployment scenarios, and we'd like to keep going on the implementation of working group draft and make feedback to the specification. And also your feedback is very welcome. So DOS is now getting popular, so DDoS protection is one of the biggest issues among network operators. So DOS working group is aiming to have interop testing as the next hackathon in IETF 100. Thank you very much. Yeah, mainly 2 people.
And you were implementing some of the drafts in the group right now?
Yep.
Okay.
Thank you.
Great. And it's nice to know that we already have some projects lining up for IETF 100 Hackathon. I'm happy to hear that. Okay, the low pan. Okay.
Hi. So, it's not here? Okay. So my name is Laurent Toutin. Okay. Okay. Okay, so my name is Laurent Toutin. I will present you something we have done on SCHIC. So SCHC is pronounced SCHIC. And it has been done with Dominique Bartel from Orange, Philippe Clavier from the University of Buenos Aires, Arun from and Ivalo from Clio, and myself from the University MIT Atlantic. So we work on a new category of network, new family of network, which is called LP1, and that has been designed for Internet of Things, because we have a very good energy, very energy efficient. For example, a device like this can run for many years on a battery. And there is also a long range, so you can cover cities or countryside very easily. So that's a very good technology for Internet of Things, and we have different technology, for example, LoRaWAN, Sigfox, Narrowband IoT, Wi-SON, etc., that exist and cover this requirement. The problem is that we don't have, if you want to write an application, you have to develop the application for this technology. So at the IETF, we have a solution when we have different technology and we want to run application on a single way, is to use IP and to put the application on top of IP. The problem is that when you look at LP1 technology, you don't have a lot of resources. For example, you can send only 1% of the time. If you look at one technology like Sigfox, you can send only message of 12 bytes. So it means that to adapt IP to this kind of constraint is very, very difficult. And that's why at the IETF we have developed a technology, SHIC, that allows to compress for this specific environment IP, UDP, and CoAP. So we arrived to the hackathon with 2 implementations of SHIC. One has been done by IMT Atlantic, and it was running on Python in the device like this one, on JavaScript on the core network. And Aclio brings its own implementation running in Golang. So what we have done during this in the hackathon is first to test interoperability between all these implementations. So we fix some bugs. We also move the application, IMT application. We also include Sigfox and LoRaWAN. So now we have device that applications that can run on all these kinds of device. And with Orange, we also test the Python implementation in the core network. So it's what we have done. And the result of the hackathon is that now we can test the solution on multi-technology. We also resolved some problem we have in the draft, or we saw in the draft, is on the padding management. We have also seen some ambiguities about some variable length field. So we have to fix this. And finally, we have defined reference implementation that can be useful for developing new implementation, and it's available on GitHub.
Thanks. How is this different from the demo you did from the last meeting?
It's different because we have now better understanding of CoAP. So now we have a full implementation of CoAP, bidirectional CoAP, all the things that are in the draft right now.
So this is different implementation that interrupts the one
yes.
you did last time. Okay, perfect, thank you.
We were 5.
Okay. And next, who do we have next? Okay, Mile. You guys ready? Great. So let me talk about what we have done. We are working for Mile. So as you may know, Mile is a working group working for instant information exchange. And this working group has completed to define a format for instant information exchange. So we wanted to have a kind of converter that can be useful for the Sticks community and also IoT community. So in this hackathon work, we did 2 work. First work is building a converter for a converter between IoT and Sticks. And the other work is extension to our own security tool that can output IoT alert. So these 2 works are done, and all works are now available on the GitHub. And this is the status of the output. For the IoT converter, we are able to provide a POC. So if we take a look at the draft has a lot of examples of IoT documents. So those examples are supported by our tool. But IoT and Sticks has a lot of classes. It was impossible to implement everything in these 2 days. So in these 2 days, we were only able to cover the converter for the examples in the RFC documents. Regarding the extension module for the security appliance of our company, we already finished producing an extension module plugin that can produce alert in IoT. Thank you. Great, thank you. Okay, and after mile, not the README, so Riot. Okay. So, oh, I see. And you want to do this one first. Okay, got it. That's full screen. Okay.
Hey, test. Okay, working. Hi, this is Peter from the Riot community. We worked on the reintegration of the OpenWSN stack in Riot. For those of you who don't know what is Riot, Riot is an open source IoT operating system targeted for low-end IoT devices such as ARM, Cortex-M microcontrollers, MSP 430 boards, or AVR 8 boards. And what is OpenWSN? It's another software platform for open source implementations of IoT protocols such as 6LoWPAN and else. And the interesting part for us from the Riot perspective was or is the 802.15.4e TISH implementation and the 6 TISH implementation of the stack, which we don't have in Riot right now. So the plan was to integrate parts of the network stack of the OpenWSN project here in the right into the Riot networking system. On the left side, you see the Riot networking system integrating our own network stack called GRRC. And the challenge was to adapt it to the northbound interface, so-called SOC. Here you can see it's CON. It's just a deprecated name. SOC is a generic network API. And the southbound interface, so-called native, is a generic hardware abstraction